Hello, Natalie Tarry here from Natematics. I have just put together a few questions to help one of my students on the topic of rearranging formulae. So I took some pictures of their questions, did like a little video walkthrough type thing, or step by step, and I thought I'm going to record this. And what I've also done as well is I've added a couple of easier questions at the beginning, which I hope in the way that I explain will help you to see the easier way of doing rearranging formulae, okay? And it is very, very similar to a part of maths that you've probably already done. So something to do with equations. So let's go. I'm just going to share my screen, and all being well, it will come up straight away. There we go. Okay, so we call it rearranging formulae. Now, it's quite often called, we just say changing the subject. It means the same thing. Okay, really? So at the top, just like solving equations. And it's if you can think about the method that you use when you're solving an equation, you do exactly the same. Okay, and by this, I'm talking about linear equations. I'm not talking about quadratic equations where you have to factorize them, etc., etc. The linear ones are very, very like this. But have a look and I'll talk you through it. So the only difference is when we rearrange formulae is you've got lots of letters in there. And as with a lot of algebra work, for some people, they see a letter and they're thinking, I can't give an answer to that. There is this really high level of anxiety among a lot of students because the answer isn't going to be numeric, thinks they can't do it. Actually, I'm going to show you how you can do it. But you have to be confident in actually knowing the answer is not numeric. Okay, right, so let's show you how. So what I've done here, and I remember doing this with a student a couple of years ago in a live lesson, was I did two things side by side. And it really, really helped her to kind of see the difference between them. So on the left-hand side, we have got an equation. And so typically get asked to solve this equation to find x. So thinking about the terminology, what value must x be on here to make that plus 7 equal 15? Now, there's a lot of questions you can kind of work out in your head. It's not the answer that I'm interested in at this point. Obviously, the answer is important and it'll give you 1 mark in your exam. However, it's the method. The method is the key thing to so many areas in maths. And the more we can think about, well, how did I do it when it was numbers? And then apply that to when it's not numbers, you will get better. Okay, so think what do we do on that one on the left-hand side? Well, the thing we're looking for is x. So at the end, we're going to have x equals something. And I quite often say to students, well, okay, so what is it we're looking for at the end? What's the last line going to look like? And quite often it's like, it's too obvious. It's just x, isn't it? And I was like, yeah, x equals something. Next question, what's in the way? What have we got to move out of the way to the other side of the equal sign to leave x on its own? Well, we've got that plus 7. And again, I'm not going to go into too much detail here because it's assuming you know how to solve equations. But here we're going to say, well, actually, we need to do the opposite to that to cancel out that plus 7. Another way of thinking of it is it goes to the other side and it does the opposite. So it's almost like when you send something to the other side of the equal sign, it flips it. So here, instead of adding 7, it's going to go to the other side and we're going to take 7 away. But remember, balancing scales, we can't just take 7 away from this side because it's just going to go like that. It's going to be much lighter. So we have to take 7 from both sides. So x equals 15 minus 7. I know some of you may say, well, why don't you just put the answer as 8? I'm leaving it like that for a reason. Okay, so I've put that step in. Now we do know numerically what 15 minus 7 is. 8. Another little tip, things like that, count up. So count up. If you find that hard to do, just go from the 7 and say, how many more have I got to count up to get to 15? Next little tip from me. You get lots of value added with my videos. Right then, on to the other side. So the words of this are different. So you've got rearrange this to make x the subject. basically that means we want at the end x equals something. Isn't that just what we've just done on the other one? So what's the thing we want? We want the x. We want to know x equals something. What's in the way? The plus p. What is p? It's representing some number we don't know. Remember, we do exactly the same to letters, the variables, as we do to numbers, because that's what they represent. So back over to this then, to get rid of that, adding p, we cancel it out by doing the opposite, which is subtract p. So do both sides. So then if we're taking p from this side, we're left with nothing. And then on this side, what have we got? It's what we've got there already. So just like here, we've got the 15, and we're taking away the thing that was on the other side, which is the p. So we end up with x equals q minus p. Can we do anything else with that? No, that's the answer. Okay. If you may, sometimes in questions you might get given, okay, rearrange the formula to make x the subject. And then subsequently, if q is this and p is this, what would x be? Or if p is this and x is this, what value must q have been? You know, those sort of things. So you just substitute in a number and get the answer. Okay, on to the next example. So here are what I would call a two-step linear equation. So that means we've got effectively two things to move over, two steps to get to x, or whatever the letter is, equals. So start with this one to start with. So we've got 3 lots of x, 3 lots of some number I don't know. I add 2 to it, I get 11. Now, I'm sure most of you would be able to work out straight away that x is 3, because you kind of do it in your head. Well, that's a 9 plus 11. I want the method, because that 9 and that 3 is going to really help you when you've only got letters here. So the thing that we want is the x. And if you've seen any of my lessons, I've got a standalone lesson on part of my training course with Everett. My algebra session is split into 2 sections, and one of them is very much about equations. And I talk a lot about which order we move things over. So for a 2-step equation, I always say that these 2 together, they've got to stay together. They're like best friends. It helps people to understand. They laugh, but then you know what? It helps them remember. And then the thing that comes along afterwards came a bit late to the party, the +2. That's the thing that has to go, because they've not got that kind of emotional connection to the x as what 3 has. Anyway, it's just a way to remember it. So here we want to get rid of the 2 and the 3. But as I just said, the first thing we need to do here is get rid of that standalone number. So adding 2, opposite of adding 2 is subtracting 2. So we do the same to both sides, and we are left with 3x equals 11, take away 2. Again, I've left that step in so you can see that, we probably leave it out when we're doing it. Ideally, keep all your steps in. But when we come to do the other one on the other side, this will make sense. So yes, numerically, we can simplify that to be 3x equals 9. So again, what's in the way now? It's that 3. Sorry, number 3, you're going to have to go now and leave x on its own. So what is the 3 doing to the x? What mathematical operation? Sounds really painful, doesn't it, that? It's multiplying. Send it to cancel it out, we divide, which is the opposite of multiply. So divide both sides by 3, and we have x equals 3. How can we check that's right? Put that answer back into the original equation, and if it's right, you should get 11. So again, just another little tip there, for to make a little note of things like that. Okay, over to the other side, and we're going to say rearrange this to make x the subject. So we've got a letter, a letter, and a letter. Just out of interest, what thing in maths has a general form that looks like this? I'm going to explain that a little bit more. So a general form means there's something multiplying by the x, and another letter added to it. B could be positive or negative. And then there's another letter on the equal sign, on the other side of the equal sign, normally y. Well, it is y, to be fair. Equation of a straight line, y equals mx plus c. Yeah? Just look out for things like that. Look at things and think, where have I seen something kind of like that? But obviously this has to be a y because it's talking about your coordinates on your axis. So you've got an x and you've got a y. All right, so what's in the way then? We've got the b and we've got the a. As before, the a sticking with the x together. They stay there till the end. The b goes over because it's not been there as long. So cancelling plus b out, we have minus b. So we do the same to both sides. What are we left with? Well, this is gone because that's the whole point of doing what we've just done. We're taking it away, so it's gone. And then we've got t here and we're taking away b. So we'll end up with ax equals what we had there originally, take away b. I can hear my daughter tizzling around, so if she jumps, she might join in at some point. I've got my ears ready for it to come in and jump and surprise me. Okay, so last step is, well, we want x. The a is in the way, so that's the next thing that we've kind of got to strip away. What's the a doing to the x? Multiplying. What's the opposite of multiplying? Dividing. So we do the same to both sides. This is a really important thing here, especially when you've got a little expression there on the right hand side, haven't you? So yes, the whole thing is an equation, but you've got t minus b. When we divide ax by a, I've not kind of put this as a substep, but what you end up with is that they cancel and it becomes x. On the right hand side, you are multiplying both that whole expression, t minus b. Because if you think about it, on this side here, t was 11, b was 2. So we said it was 11 minus 2, and we were able to, because it was numeric, you were able to give a numeric answer of 9. On this one, on this side, you can't do that because you don't know what t and b are. So you just leave it as, once I know what they are, I can work that out. And I divide the whole thing by a. I mentioned that then. When I was kind of planning this, I hadn't really thought about that step, but going through this now, I think it's well worthwhile mentioning that. And I say I hadn't thought about the step. I mean, I hadn't thought of that little reminder to tell you about it. Right then, I'm just going to pause for a second. She says if she can find it. No, can't even find it. Right, I'm going to carry on. I'm just going to have a quick drink of water. Okay, so that was kind of part of a lesson. What I've got here now are, they're not as sort of neat per se. I haven't got lots of little things going on the screen. I am going to be talking through what we do at each step. Now, this is a student who's hopefully going to be doing higher level. She's sort of at the top end of foundation. She's having the opportunity to do higher. So she's kind of going over certain subjects, certain topics. Oops, hang on a second. There we go. So, sorry, I flicked into my gallery on my computer then, so it paused. So here, I think most of these to start with are make x the subject. So we have got a equals half of x plus y. So think of the order of this, and I'll do a little bit extra on here as well for you, well, we've got x, we add y to it, and then we multiply by a half. But question, multiplying by a half is the same as doing what? That comes up a little bit later, okay? So multiplying by a half is the same as, think about KFC when you're doing nothing to do with food. When you're doing fractions and dividing by a half is the same as multiplying by 2. Anyway, let's move on. So what we're going to do, what maths can we do with what's in front of us? Well, the thing that we want is the x. So that kind of makes us think, get your highlighter pen out, highlight it, focus on the other things, because really everything else is just, we don't need it. But we must make sure that we use the correct mathematical tools that we've learnt in that process. Things like big maths, things like expanding brackets, all those sort of things, okay? So we've got half times these two numbers added together. So first thing, brackets. Yeah, BIDMAS. So we need to multiply out those brackets. So we've got a half times x plus a half times y. Yeah, and it's plus because you've got a plus there and something there. Okay, so what is the thing that we're then wanting to move out of the way? Well, looking at this, the plus half y, we definitely don't want that. It hasn't got an x in it. We haven't got any brackets to multiply out anymore. So go on, off to the other side, please. You've done your job. Thank you very much. Have a good day. So what is the opposite of adding half y? It's there, subtracting half y. Okay, so let's do that then. So we're going to subtract half y from this side. So that's going to go. That was the whole purpose of it. And then we're going to subtract half y from here, what we've already got. So remember, starting with a, we're then going to take away a half of y, and we are left with the half x there. Okay, don't worry about how complicated any of these things look. Just treat them as a number. Just copy it down. Do whatever you need to do to cancel out the thing you're moving away. Okay. All right, so let's just have a look at this equal. We've got an equal sign here. If you are not comfortable with having the thing that you want on the right-hand side, what you can do is you can flip them around, provided you keep everything exactly as it is. So, for example, you could put a half x on this side, and then put on the other side a minus a half y. It's exactly the same. Okay. I've kept, I think all the way through these, I've kind of kept the thing that we're looking for on the right-hand side, I think. But feel free to swap them around if you want to. But all we're going to do is now look to see, well, what's in the way? We want x on its own. There's a half there. What's that half doing to the x? Multiplying. What's the opposite of multiplying? Dividing. Now, I'm pretty sure I put in a question here. So dividing by a half is the same as what? So imagine you've got something and you split into two. You're dividing by a half. You're saying how many halves are in that thing? There's two. So dividing by a half is the same as multiplying by 2. So, and I've brought this up on here, KFC. So keep flip change for your divisions of fractions. I do have a lesson on fractions and decimals and percentages. So if you want that, to come and join my course, you will learn all about it in there with some useful little tips. So what I've done there is I've just said, well, actually, instead of divided by a half, I'm going to multiply by 2. Same thing. If it's a calculator paper, just do what it says. If it's a non-calculator paper, just think, how can I make life easier for myself? So we've got, we're going to multiply on the left by 2. We've got 2a. And then minus, you've got to multiply this by 2 as well. So 2 lots of a half y. Notice I put that in a bracket there, just to make sure I multiply it out correctly. So I'll do that in the next step. So then, what's 2 lots of a half? It's 1. So therefore, what we end up with is 2a minus, this becomes 1. So it's y, because we don't show 1y in algebra, we just show y, equals x. Things that look complicated, when you break them down into just little steps, it becomes a lot easier. And it's the same with anything in life. I was talking about something about mental health yesterday. And sometimes if we look ahead, far ahead, it seems like such a massive, massive thing. I've walked, has anyone completed maybe walking a long distance, climbing a mountain, for example. I've walked up Snowdon a good few times, and depending on which path you use, you go up on, and depending on the weather, quite often you can see, at some point you'll see the peak. And you think, oh my goodness, that is so high. I'm never going to get up there. Well, if you believe that, no, you won't. However, if you just keep putting one step in front of the other, then another step, and then another step, and you just keep focusing on that kind of mentality. Before you know it, you'll be at the top. And yes, there's a few steeper bits near the top, but anyway, that's another subject. Right, so next one, make X the subject. I like some of these formulas because they're like things that, you know, we've done before. So what's pi r squared? What's that formula? And what is 2 pi r? Or pi d? You've got like the circumference, haven't you? And then you've got the area. So pi r squared. So make X a subject. Highlight the thing that we want, which I think I've done. Oops, I haven't put it. I'm sorry. I thought I'd highlighted it, but I hadn't. So what's in the way? Well, pi r squared. I haven't got anything to do with X in it. So off you go. Send you to the other side. So I'm going to take away pi r squared from both sides. Happy with why we do that now. So we've got this goes over there, and we're left with this 2 pi r x on the right-hand side. So then what is in the way? Now, I don't know why I've highlighted all of that for some reason. It's the 2 pi r that's in the way. We want X on its own. The rest's got to go. So how do we get rid of that 2 pi r? It's multiplying, so we're going to divide. So divide both sides by 2 pi. Did I just do 2 pi? I meant this should be 2 pi r. This is one I obviously didn't go back and check. Okay, but the actual maths here is correct. This should say 2 pi r here. Okay, so basically I'm removing everything except from the X, and it's dividing what's already there on the right hand side. X is on its own. X is now the subject. And again, just a reminder, you can flip them around and say X equals a minus pi r squared, all divided by 2 pi r. Okay. Things like this come up in questions, lots and lots of different questions in higher level. And what's important to do is to just like, maybe you've been given a formula and there's one thing that you don't know. Maybe you've been told the volume of a shape is this and the height is this, but you don't know maybe another measurement. So you kind of say, well, what is the equation? How would I work out what the volume is? Put in the things I know, put in the things I don't know, and then rearrange it. Okay. It's a very, 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 very useful skill to be able to do this for higher level. So especially if you are somebody who has been doing foundation level and is now given the opportunity to sort of get a higher grade than a grade B, a grade 5 in the England GCSE, intermediate, if you are getting the chance to do maybe higher level, so you can get a grade higher than the B. Certain skills, there are certain things, you know, to try and cover the whole higher level course in, you know, the next few months, on top of obviously all the other things you do, and it's going to be a big ask. So certain skills, it's good to work on, and you know, I'll be working on that with a couple of students this year. So if you want to join me, message, and we can obviously get a little group together maybe. Right, we are doing a little bit of physics here now. So make X a subject. S equals uy plus a half xy squared. What's the thing we want? The X. What's in the way? Well, we need to get rid of that uy. Now, I haven't put as many steps in this one, so I've kind of left it quite raw, sort of step by step by step. Okay, so I've taken that uy over to the other side and it subtracts. What else is in the way now? Well, I want the X there, but the half and the y squared. Off you go. Thanks for your help. So obviously I've got a different one in there. So what I did here is I actually said, well, actually, I'm going to take the y squared first. What's that y squared doing? It's multiplying. What's the opposite of multiplying? Dividing. So we're going to divide both sides by y squared. So we end up with this. I've deliberately decided to do the half separate. Okay, there's a reason for it. So what's in the way now? There's only one thing left, isn't there? The half. So we're going to divide both sides by a half, which is the same thing as multiplying by 2. So again, thinking about with fractions, how do I multiply a fraction by 2? I just multiply the numerator. Okay. another little tip there. When you've got something that's s minus uy equals over y squared, bleh, for some people, I'd imagine that's probably how you feel. It's fraction. It's a number over a number. And literally, what I quite often do, sometimes it can get a bit complicated sometimes when you get, you know, sort of like A-level and higher stuff. But for yourselves, literally think, well, if that was 1/3, what would I do if I'd got 2 1/3s? We multiply the numerator. Okay, so there you go. And that is how I would leave it, to be honest with you. Right, next one. Now, obviously, I've not put the builds in here, but that's okay. So this was the question. C equals 3x squared minus y. Try and stick with me at the speed I'm doing, so then you'll hear the steps in relation to each one. So I've gone through and I've put in red the things that we don't want. We want on the other side. So just going step by step, doing the opposite to what they're doing now. So subtracting y, opposite is adding y. So the next line is we've got both sides, we've added y to both sides. So it's there and it's cancelled from here. So then we've got 3 multiplying x squared. I am going to deal with the 3 first. So I'm going to say, okay, off you go. Because remember, it is only the x that's squared, not the 3, just the x. So the 3, I'm going to divide both sides by 3. So we can see what we had there, and we divided by 3. Left with x squared. Now, obviously, you can see here now, I'm not going to go back and change it and record it again because I'm going to go out in a minute. But you've got what you had there before, c plus y over 3. Doesn't matter how many letters and numbers you've got there, but whatever is there, you take the square root of, because that's the opposite of squaring. Squaring, square root. To be absolutely accurate, and I've not put that in here, what is missing from this answer here? Because sometimes in an exam, you might be told that this is a measure, it's you are trying to find like a length or an area or something. And so therefore, the number you get must be a positive answer. When you take a square root of something, remember you could have a positive or a negative solution. So think, what's minus 3 times minus 3? So what's minus 3 squared? 9. What's 3 squared? 9. So when we come to look at the square root of 9, it could either be plus 3 or minus 3. I'm just going to share something now. I haven't done one of these lessons for a while. And you know what? I'm just telling you, I'm really enjoying this. It's like, yeah, I'm back home. I'm back home. Even though I haven't been away anywhere, obviously I've not been doing as much of this. So I have to capitalize on these times, because sometimes I'm like, not in a great place. Sometimes I'm like, so it's a life. So make x the subject. Now this one, I think, is the last one I'm doing. Well, it is. I'm going to make it the last one. What we've done on this question is the method that we use here is one that is reproduced in one particular area of maths. And it's an area of maths that foundation level students do. And it's one of those methods that normally completely throws them. Not all of them, but it's kind of like that hard top end of foundation. And it's, see if you can think where you see this pattern where you've got something equals something over something else. And the thing you want is in the denominator. See if you can think. So the thing we want here is in the denominator. So if we want x equals something, we need to get that x up to the top, don't we? So I'm going to give you a couple of little tips, and I can't remember if I did both things here. So what I wrote was, when we have a denominator and the subject is part of it, i.e. the x, we need to get that term into the numerator, or at least in front of the equal sign, i.e. it's down here, here's your line, it's got to get up here, whether it's that side of the equal sign. Okay. So if this was, say, 1/4, or say x over 4, say, maybe just write that down, s equals x over 4, how would you get that 4 so it's up on the top? You'd multiply both sides, wouldn't you? Yeah. So to get rid of any numerator and any denominator, and maybe when you have algebraic, it's time for me to finish in a minute. Algebraic fractions questions. If ever you have something in a denominator and you've got to solve it or simplify it, multiply by whatever's in that denominator. Okay, works for most of the cases. I'm not going to say all, because off the top of my head, there may be cases where you don't need to do that, but just consider if something's in a denominator, multiply both sides by that denominator, maybe even do it one step at a time. But anyway, that's another subject. And I am doing a lesson on algebraic fractions because I'm going to be doing a course for higher level students as well, starting 10th of January. Keep an eye out and message me if you're interested. Okay, so what we're going to do is we're going to multiply both sides by ax, a times x. So we end up with x. So we've got s times a times x. And remember, in algebra, we don't tend to put times. So if I was going to show what was going on, I say x times a, s times a times x. Now, what's in the way now? What's there? I need x on its own. The s and the a are in the way. So we need to divide both sides by the s and the a to leave x on its own. And that's why we end up with this here. Okay? I've not put much more in there, but that's literally what's going on. Now, what I could have done is said, well, let's just multiply both sides by a. I'm going to do that step first. So I'm just going to do the a. So I end up with SA equals m over x multiplied by a, so it's gone. And then to get x on its own, I can't remember if I've got this next bit in I want to show you. Yes, I have. I'm going to show you something that you may recognise. What have we got there? I could be a little bit more, I could be really harsh on you now, because I could say, actually, it's not one of those, because I can't prove it's what it is. Right angle triangle. Now, it isn't marked as a right angle triangle. So you could say, well, prove it to me that it's a right angle triangle. But in an exam, you would be given, it'd either have the little square in there to show it was a right angle, or you would see the words that says, this is a right angle. So imagine you've been given this question. You've got an angle of 42 degrees there. You've got a side opposite, hint, hint, opposite, it's 5. We don't know what the hypotenuse is, but we're told that x, the side we want to work out, is the adjacent side. A typical question like this might be, I've got a ladder, so it's tilted against a wall at an angle of elevation of 42 degrees. How far away from the wall must it be, given it hits 5 centimeters from the ground? Obviously, that's going to be meters or whatever, but I'm just trying to give you an example. So what will we do? We'd look at that. We'd write down perhaps SOHCAHTOA. We'd look to see what we've got. We've got the opposite and the adjacent side. And we can then write our equation that connects all of those together. Yeah. So we know tan of the angle is equal to the opposite, which is 5, divided by the adjacent, which is the thing we don't know. Oh, what have we got here? Something we need is in the denominator. Something we need is in the denominator, okay? These are the things that I think for a lot of foundation students, if they're really struggling, I just say, right, there's a little trick. What you're going to do is you're literally going to swap these two over, okay? So you're going to put the x at the top and you put tan 42 at the bottom. A good way to show this, I know I haven't done this, I've got that step by step in a second, but imagine you've got a number, say 56, is equal to, 8 is equal to 56 divided by 7. 8 is 56 divided by 7. Write that down. and then swap the 7 and the 8. So 7 is equal to 56 divided by 8. Is that true? Say, I don't know, 4 is equal to 20 divided by 5. 4 is equal to 20 divided by 5. Swap the 4 and the 5 around. Does that rule still work? So that's hopefully giving you the confidence that I'm not just making up some rule, and so you know where it comes from. You don't necessarily know tan 42 degrees off the top of your head, although there are some numbers you do need to do exact values for, but that's another thing coming. So we're obviously nearly at the end now. Thank you very much for sticking with me. So all we're going to do is swap those 2 over, and we've got x equals 5 over tan 42 degrees. And just to show you the steps, because I know for some of you might want to know, well, I'm still not quite sure what you've done there, Natalie. So we're going to multiply both sides by x. That way the x goes up to the top, the denominator goes away. So we end up with x times tan of 42 is 5. I always suggest you put the x in front. Sometimes we have a number here and the unknown side is at the top. Always put this denominator, make sure it's in front. So it's whatever that number is, lots of tan 42, because that is a number, tan of 42. So finally, what is it we're looking for? What's in the way? We've got x is equal to, and we need to divide both sides by this thing here because it's in the way. Off you go to the other side. I've got a light here. I keep not forgetting it's there. So tan of 42 degrees. So we end up with x equals 5 over tan 42. I'm going to stop sharing. There we go. Right. I don't know how long that's been going on for, but it's time for me to go and visit my mum. So, and then we're going to go to, at some point, hopefully, I'm going to take a ride on the train over to Chester to go to the Christmas market. I'm not really doing much shopping. I'm not Christmas for us this year. It's just, yeah. I'm just going to go and just maybe enjoy the Christmas markets before Morgan comes back. My son comes back tomorrow, and then I'm just rooting to the sofa. So hope you all have a lovely Christmas. And if you're watching this after Christmas, I hope you had a peaceful and nice Christmas. I slowed down too much there. I can't think what I was going to say. And if you are watching this before Christmas and you've got exams coming up, I have got some availability left now. Because I've not really been tutoring since middle of October, I think it was. Obviously I'm going to start building up again as well. If anything, more from a financial point of view as well, because it's been a tough couple of months emotionally and financially. But where are we now? So let's have a look. So New Year's Day, I'm not going to be doing any tutoring beginning of next week. Let's just have a look now. I'm going to cut this bit off at the end, but there is, if you're watching this, I am going to be tutoring after the new year. So if you want a session or two, maybe you want a group session, you've got you and your friend really struggle on a particular couple of topics or something, just let me know. And if you're watching this in the year 2025 and it's the summer, nice to see you. Drop a comment whenever you see my videos. Put something in the comments. It's always nice to see who sees them, how it helps you, and message me if you've got any questions like these questions that you think, I've tried to do this and I'm really, I can do it now, or can you give me some help on this? Do you know what? I said that my daughter was probably going to appear at some point. She's done well. I was waiting for her to come in here and shout and make me jump, but thank you, Caris. I'm going. Thank you very much. Take care. Bye-bye.